Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at port numbers. We'll be discussing multiple separate communications, socket pairs, port number groups, and the Netstat command. This episode is part of my series on Introduction to Networks for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Both TCP and UDP, they're designed to handle multiple conversations at a time. They manage it very well, and that's what they're designed to do. Once again, we're talking about maybe having multiple tabs open in your web browser, maybe multiple web browsers. You have Chrome, you have Firefox open. How does the data arrive in the correct tab? This is how we do that. Now, the source port and the destination port. That's particularly what we're talking about. The source port here is a logical port number that is associated with the originating application on the local device, on the source device. So it's a logical port number, and we'll talk about port numbers here in a second, on the originating local device. The destination port is a logical port number where it is on the destination server. A destination application is designed to listen for that port number. And so once again, the source port number is on the local device. That's the application it's from. The destination port is a logical port number on that remote device for a destination application on that remote host. Here's a couple examples of how these port numbers work. A lot of times these port numbers, the source port and destination port, they're referred to as socket pairs. When it's coming down from the OSI model, the upper levels, the layer 7, 6, 5, down to layer 4 here, we identify what is the source port. And this typically here is a random port number. A random port number. It is destined for this port number, port 21. These ports are typically well-known port numbers. In the example right here, the destination port of port 21, that represents FTP, File Transfer Protocol. And so what happens here is it is coming from this port right here. It is destined on the remote host to look for that port number, that logical port number. And down here, looking here, the FTP client uses a source port of 1350. And what it does is we build this protocol data unit here. We take our layer 4 logical port number, then we encapsulate it here in our layer 3 IP address. And so this is our layer 3 IP address. Then we encapsulate it in our layer 2 address. Right there. We send it from device network interface to network interface, rebuilding that layer 2 frame every time we go from another device, looking until we finally reach the destination of our IP address, our destination IP address. Then we de-encapsulate it, we take off all the headers, and we pass it up to the application. And then when it gets to layer 4, it says, hey, we have a logical port number of 21. We're going to route it towards the applications that listen to port 21, which is our FTP server. And so that host then has an FTP server running on it. That FTP server grabs this segment, reassembles the data, and processes the request or the data to get there. Down on the bottom, we have a web request. And what happens with this web request here is it comes from the source port here of 1099. We build our layer 4 segment. We build our layer 3 packet. We encapsulate it and get our layer 2 frame. We send it across the network. We are destined for port 80. Port 80, when we talk about that, most people go, oh, that's the web server. That is on the far end, the destination device. There's an application that's listening for port 80. And what we mean by listening is it looks at the destination port field. That application on that far computer looks at that destination port of our layer 4 port number and says, hey, that matches what I'm listening to, so I am going to take that and process that. It goes through, it processes that, and then when it sends it back, what it does is it inverts this. It inverts these two fields, basically. Well, it inverts all of these fields because now the source becomes the destination and the destination becomes the source. It inverts these, but when it comes back, it is now, this is the destination. This is now the destination. When it comes back, this is the source. And the destination, as it comes back here, this computer here, the source computer, the original source computer, it remembers. It sent out a request from port 1099. It's listening for a destination, because remember, now we've inverted these. It's listening for this 10999. It goes, oh, that's for me. This is for this application, this particular tab in a web browser. It routes that reply back to that destination. As we talk about it, these sockets, what we're talking about, just to be clear, is the socket is the combination of a source IP and source port number. That makes a socket, or it's a combination of the destination IP address and the destination port number. You combine the two destinations together, that gives us our socket. The sockets enable multiple processes running on a client to be able to distinguish themselves from each other, because we have these socket pairs, the IP address and the port number. And then we can have multiple connections to a server. We can have multiple conversations going on, handling all of this on the client. That's where these sockets come into play. I hope you're liking this episode on port numbers. If you have the time, please leave a comment and let me know what you think about port numbers. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. As we look at these layer 4 port numbers, these logical layer 4 port numbers, there are basically 3 groups of them. Remember, these port numbers are 16 bits long. If you take those 16 bits, put 1 in all the columns, so you got 16 binary ones together, convert that into decimal, you come up with 65,000. So there's 65,000 possible port numbers you have. We break those into basically 3 separate groups. 0 to 123, that's what we refer to as commonly known or well-known ports. These well-known ports are for applications that we use in a daily process. These are your web browsers, your email clients, FTP. These are standard protocols we use every day in the life of our networks. They're defined as well known for different applications, for clients, for servers. These are there. Port 80, once again, that's our HTTP protocol. Everybody, I think, has probably heard about port 80 being the web protocol or web port number. That's what we're talking about, these well-known ports. Then we have 1024 up to 49,000. These are registered ports. Once again, here is IANA. These ports are assigned by IANA, a registering internet organization that has IP addresses, but they also deal with these port numbers. And you can go and request a certain port for your application. You're going to build an application, and you want it to be available to listen all the time, to send data on using a certain port number, using in that source or destination port field, being able to have that assigned to you so nobody else is going to use it. You go to IANA and ask and get that. These are typically for individual applications. Here, looking at it, for those of us who like play computer games, Steam has their own. Any of the big video games, they typically have their own ports they use. Here, an example, Cisco has port 1812 registered for its radius server authentication. It's a process of using authentication on different computer devices. So those are registered. You can go and do that. Then from 49,000 to 65,000, these are private or dynamic ports. Basically, this is the Wild West. You can do and use any one of these ports. There is no reservations. There is no registration for these. You can go ahead and use these. A lot of times your operating systems will dynamically use some of these behind the scenes, or the different protocols or programs you're using are going to randomly pick one of these ports out to use. A lot of times port or applications use multiple ports. And so what we have here is maybe it's a well-known port or a registered port that starts off the initial communications, but then they establish up in the dynamic ports, let's use a couple of these ports up here to facilitate the main body of our communications. And so what we have here is basically the control ports are down in the well-known or registered ports, and then all the data transfer happens up in the dynamic port area. Here are the more common well-known port areas. And once again, this is a value that goes typically in the destination from a client. It typically goes in the destination layer 4 port number, and we call it a logical port number a lot of times because all it is a number in that header field that goes in from the source that goes to the destination, and this is where we're talking about. Probably the most common one most people know about down here is port 80. This is our HTTP. This is our web traffic, and most people do know that the port 80 is our web traffic, and that's probably the most common one. As you work in the IT and industry, you're going to be familiar with quite a few of these. The other one here is 443 down here. 443 is our secure web traffic. So instead of HTTP, this is the HTTPS, where we add encryption in there. As we look through here, we can see that we have FTP right here on port 20 and 21. We have our secure shell, and we have Telnet. Once again, secure shell or SSH is the encrypted version of Telnet. We have SMTP, Simple Mail Transfer Protocol. We have our DNS name service that works on port 53. And notice it's either UDP or TCP. For these port numbers, we also identify, is it a TCP? Do we need that reliability here? Or can it be UDP, where it's this best effort? There's no acknowledgement set back. We're going to get into later on talking about DHCP. We have TFTP here. We also have a couple more mail protocols down here, 110 and 143. That's our POP3 and our IMAP. And then we have some SNMP, Simple Network Management Protocol, that allows us to look at our networking devices, gather information off of it, and we can even make changes using it. These here are all of our well-known port numbers that you'll probably run into as a network administrator. Applications, they establish TCP connections to different servers. If you know what these applications are and what these TCP connections are, that's a good thing. But sometimes you may have TCP connections that you don't know about, that are unexplained, and these could be big security risks. One of the tools that we use to help identify these connections is the Netstat command. The Netstat command is a Windows command. Once again, how we can determine it's a Windows command is if we look here and look at the prompt. Here, the prompt is a C:\/ that identifies it has a C drive. This is a laptop. This is a desktop computer. If it would be a router or a switch, that would say router or switch, S1, R1, something like that. But this is a Windows system. This command, Netstat, is a Windows command. Go ahead, you type in Netstat in the command prompt, you hit enter, and it's going to show you a list of all your connections here. And It's going to give us the protocol. These are all TCP connections that we have established. The local address is the local address of our computer. And notice we have a socket pair here. We have an IP address and once again, the IP address is a layer 3 IP address. And then we have the layer 4 logical port number. And so this socket is connected to this foreign address or destination socket pair. And it's connected to 192.168.0.2 NetBIOS SSN. That has something to do on our local network. That's probably a good thing. The second line right here, once again, this would be our IP address with our port number. But then we're connecting to this 207.138.126.152. And notice, for the well-known ports, instead of saying port 80, it says what it is. And so this is web traffic. Odds are there's a web browser here browsing this website at this point in time. Down here, 192.168.124:361, it's connected to sc.msn.com HTTP. So it's another web site here. If you would type this in your browser at sc.msn.com, odds are this is a Microsoft website here, and you're opening this web page. And the final one down here is another web page at www.cisco.com. These are all there. We can explain these. Now, if you had some TCP connections that you couldn't explain, maybe you have something going on. To me, this would mean that maybe you have some spyware, malware, adware on your computer, and you want to look into this further. Netstat is a great command to help you identify these unexplained connections. It was my pleasure to provide you with this wonderful episode on port numbers. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on Introduction to Networks for the CCNA. I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.